Hi everybody, in this lesson we will do some practice problems on fractions that are greater than 1. So let's begin right away. The shaded portion shows 7 over 12, true or false. So let's see. So how many shaded parts are there? So 1, 2, 3, 4, 5, 6, 7. And what is the total number of parts? So the total number of parts is 6 here and 6 here. So 7 over 12, and it seems like it could be correct. So what do you think? Is this true or false? Actually, it's not true. It is false, but this is a common misconception. And the misconception or the incorrect idea here is that the number of parts is not 12. The total number of parts that you have to take in the denominator is not 12, but 6. Why is that? Well, because the whole is just one of these shapes. So we actually have two shapes here or two holes here. Each hole has been divided into 6 equal parts, and then 7 of those parts have been shaded or taken. And therefore, your numerator will be 7, that is correct, but your denominator will be 6, not 12. And therefore, this actually represents the improper fraction 7 over 6. And as you can see in the picture, it's actually greater than 1 because the shaded region is greater than one whole. So there's no way it can be 7 over 12. It is actually 7 over 6. So the answer to this question is false. Okay. The shaded portion shows a proper fraction, true or false. Once again, each of the squares is one whole, and each whole has been divided into 1, 2, 3, 4 equal parts. But how many parts have been shaded? So let's count them. So 1, 2, 3, 4, 5. So 5 parts have been shaded, but there are just 4 parts in one whole. So our denominator will be 4, but our numerator will be 5. And therefore, the shaded region here is the improper fraction 5 over 4. It is greater than 1. So it is not a proper fraction, and therefore this statement is false as well. Okay. Which of these shows 8 over 5? So in the first picture, picture A, we have one whole that's been divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts, and 5 of those parts have been shaded. So this actually represents the fraction 5 over 8, which is a proper fraction. It is actually less than 1, and it is visually obvious that this should be less than 1 because the shaded part is less than one whole. So A does not represent 8 over 5, it represents 5 over 8. But in B, in picture B, we have two holes, and each hole has been divided into 1, 2, 3, 4, 5 equal parts. And how many parts have been shaded? So 5 here and 1, 2, 3, 8 here in this from the 3 parts from the second hole. So total 8 parts shaded. So 8 would be our numerator and 5 would be our denominator, and the shaded region here therefore represents the improper fraction 8 over 5. It is greater than 1, and therefore B is the correct answer for this question. Alright, complete the number line. So we have a number line here. We have point 1 over here, which they have written as the whole fraction 3 over 3, also an improper fraction. We have point 2 over here, so this we could write it as the improper fraction 6 over 3, and then we have point 3 here, which has been written as the improper fraction 9 over 3. But now let's also complete the remaining empty boxes. So we have this point here. So first notice that the unit interval between 1 and 2 has been divided into 1, 2, 3 equal parts, and therefore this point here, which has been written as the mixed fraction 1 and 1 over 3, we can also write it as the improper fraction 4 over 3. Now this point here has already been written as the improper fraction 5 over 3. How would I write it as a mixed number? So I would take the whole part, which is 1, and then these two parts out of the 3 parts total. So the fractional part would be 2 over 3. So this point is the mixed number 1 and 2 over 3. What about this point here? What is this point as a mixed number? So the whole part of this is 2, and then out of the 3 parts that we have 1, 2, 3, one part has been taken. So 2 and 1 over 3 would be the representation as a mixed number. But what about the representation as an improper fraction? So this is 6 over 3, this would be 7 over 3. This point here already written in mixed form as 2 and 2 over 3, and in improper fraction form this would be 8 over 3. So that's it, we have completed all the boxes. So that completes this question. Alright, the last problem of this lesson, what is the distance between the red star and the blue heart? So the red star is over here and the blue heart is over here, and then let's say we call this 0, this point over here, and then it says from here to here is 1 inch. So we'll call this point 1, we'll call this point 2, and this would be 3, and this would be 4. Now observe that every unit interval has been divided into 2 equal parts, 1, 2, and we need to find the distance between the red star, which is this over here, and the blue heart, which is this over here. So this is the distance we need to find. So how many parts do we need to take? So that's 1, 2, 3, 4, 5 parts. So 5 would be our numerator, and then remember every unit interval is being divided into 2 equal parts. So 2 would be our denominator, and therefore this distance is the improper fraction 5 over 2 inches, and that's our answer. So that completes this lesson. I hope you liked it. Thank you for watching.